Okay, today's lesson is based on geometric number patterns. It's based on the sum as well. And we're going to try and go as far as we can. Geometric patterns. I'm aiming to finish by sum. We can try for that. I'm also trying to get to sum to infinity, so let's work, but I also don't want to rush. We can do this in two parts. For geometric patterns, there's a few formulas that we need. The first one is Tn equals to A multiplied by Rn minus 1. That's the basic formula. The next one is the sum formula. Generally, there is two sum formulas that you can use. I'm not too fussy. We can use either one. So this would be A into 1 minus R to the power of n all over 1 minus R. Okay, so questions like this and parts like this are quite simple. We'll be able to use it, but we also have the sum to infinity. Now, geometric patterns are the only ones that have sum to infinity. And this would be A over 1 minus R. We're going to call this a level 1, level 2 lesson. Exam questions will be done in a different lesson. Now, regarding this one, for the general formula, we need to remember that this is a ratio. To get the ratio, we go term 2 over term 1. Okay. Now, there is one formula that's not taught in school, and this is called R to the power of y minus x. And that equals to delta y minus delta x. I'll teach you guys how to use this very soon. But this formula allows you to find unknown ratios very, very quickly without doing the whole simultaneous thing. Okay. Now, generally, this is not taught in school, but it is used quite a bit. We're going to start off with a very basic question, and we're going to work up to the next parts. But let's start off with a formula like this. Let's go with a basic formula: 4, 8, 16. Let's go with 32. And then let's go with 2 empty spaces. This is part 1. So it's not even the sum. It's just the basic part. So what I would deal with is I would look at this and I would say, hey, term 2 minus term 1 is 4. Term 3 minus term 2 is 8. And term 4 minus term 3 is 16. Then I would go again 4, 8, and then I would see, nope, this doesn't work out. This is absolutely impossible to be linear. It can't be arithmetic. It can't be quadratic. So it's none of the above. So it has to be geometric. Now, if it's geometric, what we can do is use the ratio. We can say term 2 over term 1 and always test it out with term 3 over term 2. So that is going to work out. Let's try and see what happens. If we go with term 2 over term 1, we get 8 over 4. And then we get 16 over 8. And we get 2 and 2. So now I know the ratios times 2, times 2, times 2. Okay. Now, question 1. It's not always question 1, but there's only 5 questions they can ask you for geometric. Question 1 is, what is the next 2 terms? Of course, this is times 2, which is 64. Of course, this is times 2, which is 128. So that's all. Now, question 2, what can they ask me? They could ask me, what is the ratio? Guys, I'm not putting this in order. It's just questions that they can ask. So what is the ratio? That's fine. Question 3 is, what is the Tn formula? Now this one is, it's either going to come across as Tn formula or it's going to come across as nth term. Now it's up to you guys to decide how you're going to deal with this, if you're going to memorize it or not. But these two just means calculate the formula. So the formula is quite straightforward. Tn is equal to A times R to the power of n minus 1. We can deal with this because A stands for the first term, which is 4. R is 2 and n minus 1. And this is the Tn formula. Done. Game over. But do not go and do this. Do not go and do this. Do not tell me that 4 times 2 is 8 to the n minus 1. That is wrong. I've seen a lot of people do this, where they multiply and tell me it's 4 times 2 is 8. I mean, 4 times 2 is 8, but you can't deal with it with this formula. The next question that can be asked, question 4, is to calculate, let's say, term 10. So for term 10, it's quite easy. Tn equals to 4 multiplied by 2, 10 minus 1. And this would be 4 multiplied by 2, 10 minus 1. And that is 20, 48. So when they say calculate term 10, guys, pay attention. Calculate term 10. That means you're going to substitute 10 into n. Okay? So 10 must be substituted in n. Now the opposite question, the one that works with this, is the one that people get confused with. If Tn equals to 2048, calculate n. And this question is the opposite. Tn equals to 4 multiplied by 2, n minus 1. Okay? And now we have to work with this, right? Because 48 equals to 4 multiplied by 2, n minus 1. And we have to work backwards to solve it, right? You would use logs if you can, if you know how to. That's divided by 4. So 48 divided by 4 is 512. That's 2n minus 1. Most of the time, guys, you can just use shift fact. So put 512 into your calculator. Press equal. Press shift and fact. So if you don't have the shift fact button, because some of the silver calculators don't, I think it's the Australian ones. So one of them don't have shift fact. Then it's fine as well, because then we can just use logs. And this is 2 to the 9 equals to 2 to the n minus 1. Cancel, cancel. 9 equals to n minus 1. And if I take the minus 1 over, it becomes plus 1. 9 plus 1 is 10. The counterpart to this would be is. They would ask is. Maybe they could say, is Tn a part of the sequence? We could change the question. Is Tn a part of the sequence? Now what you would have to say is yes or no. You would say yes if you get a whole number, and you would say no if it's a fraction, or if it's like a decimal, right? So is this a part of the sequence? I would say yes. Now the last question is unknown terms. There's an easy way and there's a difficult way. I'm going to teach you a way that the school does not use very often. Let's take the exact same pattern. 4, 8, 16, 32, 64, right? Let's remove all of it actually. Let's put some unknowns and let's remove all of this. And now if I just gave you this pattern, but I tell you, listen, this is geometric. Solve the unknown terms. What you would do is label it. This is term 1, term 2, term 3, term 4, term 5, right? Now guys, I want you to understand when it comes to this formula, sometimes maybe it's a bit difficult at the start. But once you understand it, it's quite simple. The y and the x are the first and second terms that you take. They are the term numbers. They're not the actual numbers. These are the term numbers. The subscript y, the subscript x, are the actual terms. Okay? So if we deal with this, it's quite simple. You and I can work with this very simply. Right? So r is equal to y, which is term 5, minus term 4, all over term y, which is 64, and term x, which is 4. Now, guys, the y and the x don't matter. The truth is it doesn't matter. The first term that you specifically pick would be x and subscript x. The second term that you specifically pick would be y and subscript y. So it's up to you guys to decide. And now we can solve quite easily. This is r to the power, oh, why I put 4 here? This is 1 actually. Sorry guys, 5 minus 1. So this is r to the power 4 equals to 64 divided by 4, which is 16. When I root by 4 and I root by 4 to solve, I get r equals to 2. Now guys, we just solved this without simultaneous very, very, very simply. Because now I know r is times 2. So 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. And that's every possible question that can be asked for geometric number patterns. Not the sum of geometric, but just the basic geometric number pattern. There isn't anything else that can be asked. This formula that I taught you guys, it's not used in schools, but generally it can be solved quite simply. Okay. Now, the next part that we move on with is going to be the sum of geometric, but we're going to stop for a second. Okay, we'll call this part, let's call this part B. This is the sum of geometric number patterns. The sum of geometric patterns, let's just call it sequences, but let's call it finite, right? So there's an end to this one. This one doesn't go to infinity. Now, guys, most of the time you're going to see something like 10 plus 20 plus 40 plus. Now, a lot of the times when you see dot, 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 you need to understand, hey, this pattern is going to infinity. But when you don't see these dots and it just continues, it's very simple for us to work with it. Because there's only two types of questions that can be asked with a finite geometric series. There's only two types, guys. Type 1 is, question 1 is calculate the sum of maybe 20 terms. Let's say 20 terms. Now, guys, what you could do is you could go 10 plus 20 plus 40 plus 80 plus 160 plus 320 plus 640 and continue. But what happens when they say 500 terms, 5,000 terms? I mean, they don't, but if they did. So what we do is first is we would find the ratio. I can see the ratio is times 2. It's my question, so I know it's times 2. But it's quite simple. Now, you and I would say Sn equals to A into 1 minus r to the power of n all over 1 minus r. Now, A is the first term in the pattern, which is 10. 1 minus r is 2. N is the number of terms that they specifically picked, which was 20, all over 1 minus 2. This is all calculator work, so guys should be fine. Let's double check. That's 10 into 1 minus 2 to the power of 20, all over 1 minus 2. Okay, guys, it's a very it is a very unrealistic number, right? So I mean it's a number, But I picked a very weird number. I picked 10, 48, 5750. What's that? That's 10,485,750, right? Let's make it a bit, let's make it more realistic to deal with, just so we can keep it, right? And let's change this to 10. I made up this question, so yeah, okay, that's a little bit easier to work with for calculations. So 10 to 30, 10,230. I mean, 20 terms was correct as well. It's just that to keep using 10 million, it's going to be kind of annoying. So question 2 that can be asked is, guys, question 2 is quite simple as well, right? I said there's 2 questions, but technically there's 3. They would give you 10 plus 20 plus 40 plus dot 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 plus, let's call this n. Let's call this n. Now, I would tell you calculate n if Sn equals to 10 to 30. Now, you and I know n is 10, but let's go and calculate it. Sn equals to a into 1 minus r to the power of n all over 1 minus r. We substitute what we know. We know Sn is 10 to 30. We know the first term is 10. 1 minus, we know r is 2 because we calculated it before. That's n, and this is 1 minus 2. We can solve. Let's simplify. This would be 10 over 1 minus 2 to the power of n all over minus 1. This is basic algebra, guys. 1 minus 2 is minus 1. I'm going to take over minus 1 as multiplication. And I end up with minus 10,230 equals to 10 into 1 minus 2 to the power of n. I would take this over as division. And this should be minus 10 to 1023 equals to 1. And there. I would take plus 1 over as minus 1. I'm taking it step by step, guys. This would be minus 1024. And that equals to minus 2 to the power of n. Now, guys, cancel, cancel. Most of the time, shift fact would work here. But if it doesn't, then we got a problem. But shift fact should equal to 2 to the power of 10. And this equals to 2 to the power of n. Cancel, cancel. 10 equals to n. Right? There's one more question that we deal with. When it comes to question 3, question 3 is 10 plus 20 plus 40 plus dot 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 plus 5,110. Calculate the sum of this sequence. So there's 2 parts to deal with this, right? The 2 parts that we deal with is firstly, what I do is I find out what is the last term. I need to know what term is this. N is equal to something that I don't know. I don't have the sum, and I don't have any part of this. So what I'm going to do is I'm going to say Tn equals to A times R, n minus 1. Tn equals to 10 times 2, n minus 1. This is part 1, right, of the question. I would substitute the last answer there, 5120, and I would try and solve for n. Where is n? Now, when I solve for this, let's take it over. 5120 divided by 10 equals to 512 equals to 2n minus 1. If I do shift fact, let's just call SF. Shift fact gives me 2 to the power 9 equals to 2 to the n minus 1. Cancel, cancel. 9 equals to n minus 1, and then n equals to 10. Now, the fact that I know this is term 10, and the pattern ends at 10, basically part 2 is quite simple. Part 2 is Sn equals to a into 1 minus r to the power of n all over 1 minus r. A equals to 10 into 1 minus 2 to the power of 10 all over 1 minus 2. And again, you and I should be able to solve this. Let me just double check my answer. But if I remember correctly, I think we got this answer twice. So so this is 10 to 30. So that's all there is to do for sum of finite series. There isn't much. Right? To be honest, this is all they can ask you. Of course, there's different questions, but every single question that they ask you going forward on sum of finite series will deal with one of these 3 questions. Even if it's level 4, if you can deal with these 3 questions, you can deal with all sum of finite this thing. But it is going to be tricky. Right, guys. The next part is a little bit difficult, but we're going to try and make it simple. We're going to call it part C. So part C is the sum to infinity. When it comes to the sum to infinity, we need to understand that this only works. It only works for geometric, right? This formula that we use only works for geometric. It doesn't work for linear. It's not going to work for quadratic. So linear is a nope. Quadratic doesn't work. So it's only geometric, but there's also another rule. I'm going to try and not teach it correctly. I'm going to teach it simply. Part 1 is this does not work when the pattern is getting bigger. Look at this. 5 plus 10 plus 20 plus 40. Now, there's a right way and there's a wrong way to do it. The right way, of course, is needed. But let's learn it the easy way first, right? This is times 2, times 2, and times 2. Guys, I mean, this is not the correct way to learn it, but it's the easiest way. So let's go with this. If the pattern is getting bigger, the sum to infinity does not work. Okay, so if you see the pattern's getting bigger and bigger and bigger, like 5, 10, 20, 40, 80, 160, sum to infinity doesn't work, right? If the pattern is getting smaller, right? I'll teach you guys correctly in a few moments, but if the pattern is getting smaller, now the pattern gets smaller and smaller and smaller, and you see it's keep going in that way, the sum to infinity works. But please don't go and say this in the exam. It's just for you guys to understand so you don't get tricked. They give you all a diverging pattern, you get tricked. But the way that it really works is this way. This is how we are supposed to deal with it. Let's go with 40 plus 20 plus 10. We can see this pattern is getting smaller, so we know the sum to infinity works. The thing is, we need to write it properly. This is r is equal to half, r is equal to half. So the word for this is converging, right? And there's a lot of questions where we're going to have to deal with the word converging, right? So when the pattern is getting smaller, it converges and you can calculate the sum to infinity. But how do I know it's converging? It's when r is less than 1, okay? But greater than -1, right? So this is how I know it's converging, because R has to be a fraction, guys. Let me just put it down into 0. If I have a number pattern here, if I have 1 here, if I have -1 here, if I have 2 here, and if I have -2 here, guys, R has to lie in between here. This is converge. Anything else is diverging. So we don't want this and we don't want that. So as long as R is a pattern and R is a ratio that lies between -1 and 0, we're good. The reason I don't want to say fraction is sometimes you could have a fraction like this, 3/2. But 3/2 is 1.5, and 1.5 is bigger than 1. So the pattern's going to get bigger. So the right way is to say if the pattern converges, if R is less than 1 or greater than -1, and that's when we can calculate the sum to infinity. But on the same question, if we change this around, now we can see the sum to infinity does not work. Why? Because it diverges. And when it diverges, R is definitely bigger than 1. It could be less than -1 as well, but the pattern is getting bigger. And the sum to infinity does not work. You can calculate the sum, but you can't calculate the sum to infinity. Why? Because it actually goes to infinity. The answer is going to be infinity because the pattern is going to get bigger and bigger and bigger until it goes to infinity. But if you ever watched any anime and you saw Gojo's infinity part, I mean, what happens to the sum to infinity is when things start to converge, it starts to get smaller. They'll start off halving and then going again and again and again and again and again and again until it gets so close, it'll never really reach the 0. It will keep halving and halving and halving until it gets to this point. But it will never touch 0. But also, the values become so, like I'm just giving an example, so small that it doesn't even matter if you add it together. That's how bad it becomes. It becomes so small that it would never reach this point that it needed to reach. But also, you wouldn't be able to see it. But that doesn't matter as well, right? The convergence part. This thing, all you need to know is that if the pattern's getting smaller, calculate the sum to infinity. If the pattern's getting bigger, you can't calculate the sum to infinity. Let's go and do a question. There's a few questions that can be asked. You can work backwards or forward, but I mean, the sum to infinity is generally an easy question. Calculate sum to infinity. Guys, what's going to happen is on Teach-sa, on the course that you'll click now, tomorrow morning, there'll be a quiz based on this lesson. It'll be a quiz that you guys can submit and it'll get marked automatically, right? There'll also be a homework question that would be loaded on that quiz. So yeah, guys, let's start to use the course properly. Please submit the quiz directly after the lesson, okay? From next week though. Calculate the sum to infinity. Let's pick some numbers. Let me not pick a faulty number like last time where I end up with millions and billions, but we can't. You know why? Because the number's getting smaller. Guys, the ratio I would test first is a half. And because the ratio is a half, I can calculate the sum to infinity. The sum to infinity formula is generally easy. That's a over 1 minus r. A is 10, 1 minus half. And the sum to infinity, no matter what happens, when you add it to infinity, it should equal to 20. Question 2, the exact same thing can work. If the sum to infinity is equal to 20. So the sum to infinity is equal to 20. Calculate A. Okay. Let's say they gave us R is equal to a half. I'm just giving that. I made the question up. So S infinity equals to A over 1 minus R. Substitute what you're given. You're going to be given the infinity value is 20. A is unknown. That's 1 minus half. And now, guys, all you have to do is solve. 1 minus half is half. That's 20. Take that over as multiplication, and 10 equals to A. I mean, it makes sense. Even if they gave you A and they made you solve for R, this is not part of the question. I just made this up now. I just want to show you guys. The algebra is quite simple, guys. But we're doing algebra lessons as well, so you guys don't have to panic. Look at this, right? Even if they gave you the unknown R, I mean, you could cross multiply. You could do a lot of things. I mean, you could take this factor over as times. So we end up with 20 into 1 minus R equals to 10. You could take the 20 back over as division if you wanted to. I mean, you got no choice. You could distribute, but then that doesn't become very fun. It's extra work. And you're in matric, so you need to save as much time as you can. And then half, and we have to take plus 1 over as minus 1. That becomes minus half, minus R, and we know R is equal to half. But this is basic algebra. It's not part of this lesson. But that's all there is to this question. Literally, there isn't much more that can be asked, and I think we did move fast enough. So I'm able to do sigma notation as well. Am I? Yes, I am. I'm able to do sigma notation.